Hello. Okay, we shall now calculate the sunset diagram. And that's given by this one. This momentum is P plus L2 minus L1. Now, this has a symmetry factor of 1 over factorial 3 because coming from the interchange of these three lines. And then there are two vertex factor lambda mu to the power epsilon whole square. And then there are two loop integrals. L1 and L2, so L1 square plus M square, then L2 square plus M square times P plus L2 minus L1 whole square plus M square. And this integral is, of course, I3 that we calculated earlier. This is the definition of I3. This is precisely the integral that we have here. And the result we calculated was given by this minus 1 over d minus 3 and so on. Okay. So minus 1 over 6, that's factorial 3, then lambda squared mu to the power 2 epsilon, and 1 over d minus 3 m square kp plus p mu k mu of p. Now, if I write d equals 4 minus epsilon, then it is 1 minus epsilon, 1 minus epsilon inverse. And if you do the binomial expansion of 1 minus epsilon to the power minus 1, and then we get this. So we basically have to epsilon expand Kp and P mu K mu. So let me start with Kp. And that result is gamma 4 minus d divided 4 pi to the power d. Let's see where Kp was calculated. This is a result for Kp. That's what I'm writing here. And by writing d equals 4 minus epsilon, we write everything in terms of epsilon. 4 pi to the power 4 minus epsilon, then gamma epsilon so so this is minus epsilon by 2 times integral dy 0 to 1 minus 1 plus epsilon by 2 divided by p squared. Now the x integral, if you focus on that, you see this x times 1 minus x is a well-behaved function for 0 less than x less than 1. But at x equal to 0 and x equal to 1, this becomes 0. But because its power, although it's negative, but epsilon is small, so this integral at x equal to 0 and 1 does not give in divergence because epsilon is small. However, that's not true for the y integral. When y goes to 1, then this portion diverges because it has minus 1 plus epsilon to the power epsilon by 2. So y integral diverges. And the divergence comes from y going to 1 region. So this is finite. This has divergence from y going to 1 region. Then what I will do is to take out the m square factor from this and write 1 over 4 pi to the power 4 gamma epsilon, then 4 pi to the power minus epsilon, which is 4 pi over m square to the power epsilon. This m square comes by taking out this m square factor from this one. And then I will write For the y integral, I will write 1 minus y to the power minus 1 plus epsilon by 2 times 1 over this with m square taken out. So that I will write as exponential minus epsilon log p square over m square. Okay. And then expand this exponential, that would be a power series expansion in epsilon as well. So now we can see that divergence coming from the y integral in the y going to in the y going from the y going to 1 region in the limit epsilon going to 0 that we noticed here, that we can see here again. Now we have expanded it in power. You have expanded this in power series of epsilon. So this first term in the exponential, this exponential has been expanded here. The first term, which is 1 multiplying this has a divergence from the y going to 1 region. Okay, it gives divergent contribution in the limit epsilon going to 0. But if you take the second term, then in this y going to 1 region near y equals 1, these two terms are negligible. So it is log y, and one has to show that this times log y is does not produce a divergence. So let us first note down that this gives divergent contribution . Which comes from the region y going to 1, and no divergence from here because the integrand goes as 1 minus y times minus 1 plus epsilon by 2 times log y. Near y equals 1, we have this 1 minus y to the minus 1 plus epsilon by 2, and these two terms, only this term dominates log times log y. That is how the integrand behaves. And now if you write y equals e to the power x, so this is near y equals 1, then this is 1 minus e to the x to the power minus 1 plus epsilon by 2 times x. This is near x equals 0. And if we expand this exponential, then we get x plus half x squared and so on, minus 1 plus epsilon by 2 times x. Which is same as x to the power epsilon by 2 times 1 plus half x. If I take x factor out from this quantity within first round bracket, then that is x to the power minus 1 plus epsilon by 2. There is a factor of x. So it gives x to the power epsilon by 2. And inside the round bracket, I have this. And in the limit x going to 0, this basically goes to 0 as epsilon goes to 0 plus. Right, that is the reason. So since there is no divergence from the second term, it will produce a finite contribution, but it multiplies a factor of epsilon. So epsilon times something finite. That epsilon is multiplying gamma epsilon, and gamma, this is finite in the epsilon going to 0 limit, but gamma epsilon has 1 over epsilon pole. So that 1 over epsilon pole multiplying this epsilon will give you a finite contribution. So that means this quantity, this term is going to offer a finite contribution to the quantity Kp. So let us note that here. So basically what we have is this entire quantity times this integral multiplying 1. We should have poles, epsilon poles from that part. We have to calculate it. So let us do that. So what we have found so far is Kp is equal to 1 over 4 pi to the power 4 gamma epsilon 4 pi by m square to the power epsilon integral dx 0 to 1 x 1 minus x minus epsilon by 2 integral dy 0 to 1 y 1 minus y minus 1 plus epsilon by 2 plus finite. Now we have to calculate the pole structure, and we have to analyze both the x and y equations. So to compute pole structure, use this beta function, which is gamma A, gamma B over gamma A plus B, and that's given by y to the A minus 1, 1 minus y to the power B minus 1. Using that, let us first look at the x integral. The x integral is given by 0 to 1, x to the power minus epsilon by 2, 1 minus x minus epsilon by 2, and that is gamma 1 minus epsilon by 2 times gamma 1 minus epsilon by 2 divided by gamma 2 minus epsilon. So this is gamma 1 minus epsilon by 2 whole square. I'm just identifying the value of small a and small b from this expression. Okay, by identifying this form with this form and finding the value of small a and small b, and then substituting those values of a and b here in this expression to write this. And this gamma 2 minus epsilon can be written as 1 minus epsilon times gamma 1 minus epsilon. So earlier we need an expansion of gamma 1 plus some small number, say delta. We earlier had, let us calculate that expansion. So gamma 1 plus delta is delta times gamma delta, and earlier we had gamma minus n plus epsilon, where n is equal to 0, 1, 2, 3, etc. We wrote down that result, right? So let me use that result here. So this is same as delta times, so let me write it, delta times gamma minus n plus delta with n equal to 0, and minus n plus delta, that formula for that, which was given earlier, is minus 1 to the n over factorial n, 1 over epsilon plus psi n plus 1 epsilon by 2. Sorry, I'm writing epsilon, I should be writing delta psi n plus 1 plus delta by 2 . So there is an order delta. Let me not write it down here because I may not need it. I think I don't need it. At n equal to 0. So this prefactor here is 1, and therefore it is 1 plus delta psi 1. Okay, plus order delta square. This is the result. Now gamma 1 minus epsilon whole square is I use this formula here. Delta is minus epsilon by 2. So 1 minus epsilon by 2 psi 1 whole square. I mean, plus order epsilon square whole square times 1 minus epsilon inverse, and that binomial expansion will be 1 plus epsilon plus order epsilon square. Times gamma 1 minus epsilon inverse. So it is the same thing here, but with power minus 1. So 1 minus epsilon by 2 psi 1 plus order epsilon square power minus 1. So this first term, first factor is 1 plus epsilon psi 1 plus order epsilon square. Not so this is minus because it is coming from 2ab factor. So 1 square is 1, and then this square will be within order epsilon square. It is the 2 times 1 times this factor is this one. And this is 1 plus epsilon by 2. There's a small mistake here, I think. So this is the expansion for gamma 1 minus epsilon, and we have now in this factor is gamma 1 minus epsilon inverse. So it should be 1 minus epsilon. So there will be no factor of half here. So I would expand up to order epsilon. Here, this quantity, if I expand it up to order epsilon, neglect order epsilon squared term, then the consequence of that is that so the pole that is going to come is from here, and we shall see that this part is also has a 1 over epsilon pole. So therefore, all together, both terms taken together will be 1 over epsilon square pole. If I neglect epsilon square term, that means I'm not calculating the finite piece. And that is true because I haven't calculated the finite piece. In fact, for this earlier calculations, we have calculated the finite piece. But in this calculation, calculating the finite piece is not easy. So we will not be calculating it. We will calculate only the pole structure. So that is why I'm expanding the x integral only up to order epsilon. And if you expand it up to order epsilon, then you see there's a first term is 1, that is a product of these 3 1s, and then minus epsilon psi 1 and plus epsilon psi 1 will cancel. So only one epsilon will remain. So it is 1 plus epsilon plus order epsilon square. Should try to get some space here. Let's calculate y integral now. And you can check that this will be given by gamma 2 gamma epsilon by 2 divided by gamma 2 plus epsilon by 2. And this gamma epsilon by 2 is nothing but leaving aside this delta factor. This is gamma delta, the expansion of gamma delta when n equal to 0, which is this factor is 1. So this is 1 over delta plus psi 1. So gamma 2 is 1, and then gamma epsilon by 2 is 2 over epsilon plus psi 1 plus order epsilon. Gamma 2 plus epsilon by 2 is 1 plus epsilon by 2 times gamma 1 plus epsilon by 2. One plus epsilon by 2 inverse is given by 1 minus epsilon by 2 plus order epsilon square. And 1 plus gamma 1 plus epsilon by 2 we have already calculated. This is gamma 1 plus epsilon by 2, where delta is epsilon by 2. So 1 plus epsilon by 2 times psi 1, and it is downstairs. So 1 minus epsilon by 2 times psi 1. 1 minus epsilon by 2 times psi 1 plus order epsilon square. Okay. So if you take 2 by epsilon times 1, 1, then you get 2 by epsilon, that's the pole. And then order 1 term can be obtained by multiplying 2 by epsilon with this term, minus epsilon by 2 and 1. So that is minus 1. Then 2 by epsilon times 1 times minus epsilon by 2. Times psi 1. So that is minus psi 1. 2 by epsilon 1 minus epsilon by 2 times psi 1. That is minus psi 1. Then order 1 can be obtained by psi 1, 1, and 1. So that is plus psi 1. Any other term will be order epsilon or higher. So it is 2 by epsilon minus 1 plus order epsilon. That is the pole structure for the y integral, and x integral is finite. This is the x integral, which is finite, and this is the pole structure for the y integral. Combining these two results, now we will calculate the pole structure for Kp. It is given by 1 over 4 pi to the power 4 times 1 over epsilon plus psi 1. That's gamma epsilon. That is the gamma epsilon factor. Then 4 pi by m squared to the power epsilon can be expanded as we have done earlier several times. Then the x integral, which is 1 plus epsilon. Then the y integral 2 by epsilon minus 1 plus order epsilon. So this 1 over epsilon times 1, 1, and 2 over epsilon will be will give the pole 2 over epsilon square. Then let's find out 1 over epsilon term. So 1 over epsilon times 1 times 1 times minus 1. So it gives you minus 1. Then you can have 1 over epsilon. So then you can have 1 over epsilon times epsilon times 4 pi by okay, so let me do it in parts. So let's take this, let's keep this part aside first. Just to simplify the calculation for now, let us consider only these 3 factors. Then we have 1 over epsilon 1, 2 over epsilon gives you 2 over epsilon square. Then 1 over epsilon times 1 times minus 1 gives this minus 1. Then another combination, which is psi 1 times 1 times 2 by epsilon, is also 1 over epsilon. So that's 2 psi 1. Anything else is order epsilon. and then 1 plus epsilon log 4 pi over m square plus order epsilon square. So then if you do the same thing for the next two factors, these two factors, then the result you get is 2 over epsilon square plus 1 over epsilon times 2 plus 2 log 4 pi by m square. Yeah, so it is 2 by epsilon square plus 1 over epsilon 1 plus 2 psi 1 plus 2 4 pi square. So I have done these two slides starting from. So this is the pole structure for Kp. We will next find the pole structure for P mu K mu. Maybe let me finish the pole structure for P mu K mu because it's not going to be too long. So let me finish it here. This is given by P squared 3 minus D times gamma 3 minus D divided by 4 pi to the power D integral dx 0 to 1 x into 1 minus x d by 2 minus 2 integral d by 0 to 1. If you now write it in terms of epsilon, that will become P square minus 1 plus epsilon gamma minus 1 plus epsilon by 4 pi to the power 4 minus epsilon times dx 0 to 1 is 1 minus x minus epsilon by 2 integral d by 0 to 1 is 1 minus x. Sorry. it is y to the power epsilon by 2 times 1 minus y times p square y 1 minus y square. Now, in this case, so earlier we had the same x integral, which did not have any divergence. So this also doesn't have any divergence, and in this case, it is in the limit y equal to 0. This is finite, and in the limit y going to this is also absolutely finite. There is no divergence in this, and neither from y equals 0 nor from y going to 1. In both the cases, the function goes to 0. So both these so there is no divergence at all. Need to compute only order 1 term. Therefore, set epsilon equal to 0. And if you do that, then the integration will be integral dx 0 to 1 integral dy 1 minus y. If you set epsilon equal to 0, because epsilon equal to there is no divergence piece. Since there is no divergence piece, you can just set epsilon equal to 0, then that will give you the order 1 term. And that if you do that, then this is the integral. The entire these two integrals become this, and the result is half. Now, minus 1 plus epsilon times gamma minus 1 times epsilon is equal to gamma 1 minus 1 plus epsilon, which is gamma epsilon. And when you do this by this expansion 4 pi to the power 4 minus epsilon, that also is finite. So epsilon going to 0 limit, this is finite. So only gamma epsilon gives a pole. This one gives a pole, and if you are interested only in calculating the pole, then that's enough. Then you don't have to calculate order epsilon terms from the factors, because it is pole 1 over epsilon pole times order epsilon term will give you order 1 terms. So order 1 terms, so we are not calculating the finite piece, the order 1 term, which are not calculating anyway, previous calculation also. So we are only looking at the pole. So therefore, we can just set epsilon equal to 0 here for the 4 pi to the power minus 4 minus epsilon factor, and that gives you p square over 4 pi to the power 4 times gamma epsilon times the integral that we have, which is half, plus order epsilon. And gamma epsilon also has a pole 1 over epsilon. So the result is p square over 4 pi to the power 4 times 1/2 epsilon plus order epsilon, order 1. So this is order 1. Okay, so that's the result for the sunset. This is the result for Kp, and this is the result for P mu, K mu. Okay, so I have done 2 slides. I'll just flash it.